Okay, hello. So this is video 2 from section 3.5, and next what we're going to talk about we're going to talk about vertical shift down example. So let's talk about vertical shift down example. Okay, so use graph. Use graph f of x equal x squared to obtain the g of x, which is equal x squared minus 4. So like you see, g of x looks like original function. The only change is that we have that negative 4, which will be vertical shift down by 4 units. And then what we need to do, we need to find the domain and range. The domain and range. Range of g of x. Okay, so note g of x is vertical shift of f of x by 4 units down. Okay. So in previous example, we graphed already f of x, which is x squared, and we had 3 major points, 0, 0, 1, 1, negative 1, 1. So we're going to use those points. And now we're going to graph g of x, which is x squared. I'm writing on it, it's so complicated. X squared minus 4. So we're going to use exactly the same x coordinate. What's going to happen to the y values? You take the original y value and subtract 4. So 0 minus 4 will have negative 4. Then the next point, we're going to use exactly the same x coordinate, which is 1 of the second point of original graph. And the y value, what's going to happen, you're going to take original y value, which is 1, and subtract 4. So that point will become just 1, negative 3. And we're doing the same thing with the third point. Originally we had negative 1, 1, but now we're going to have negative 1, negative 3. Again, we're doing the same type of work. You take your original y value, which is 1, and you're subtracting 4. So that point will become negative 1, negative 3. So let's graph it. Graph f of x and g of x together. Okay, so let's graph them. Let's use pencil. Y, x. So f of x, which is x squared, I'm going to graph in black. So we have a point 0, 0, 1, 1, and negative 1, 1. Parabola, open up. That's the parent function, that's the original one. G of x, we're graphing in blue, which is equal x squared minus 4. So our vertex, this original point was pushed 4 units down, 1, 2, 3, 4. So we have a point 0, comma, negative 4. The point 1, comma, 1 was pushed 4 units down, so we're going to end up with 1, comma, negative 3, which is right here. And the point negative 1, 1, it's going to be pushed 4 units down, so we end up with point negative 1, comma, negative 3. So this is g of x. Okay, g of x. So like you see, the same type of graph, we just push entire graph down 3 units. So what you want to remember here, like you see, no changes regarding x coordinates, they staying the same. The y values of original graph was affected, like you see, they change by taking original y value and subtracting negative 4, because that negative 4 represents our vertical shift down. Next, what we need to do, we need to find the domain. Domain of g of x. So domain, that's your x values. For x values, you can pick any x you wanted, so it's going to be from negative infinity to positive infinity. So that's our domain, from negative infinity to positive infinity. And the range of g of x, that's the y values. So like you see, this is your function g of x, y values. So the first point of g of x, it's 0, comma, negative 4. So the range will be from negative 4 to positive infinity, and range, it's different comparing to original graph, which is x squared. For original graph, the range was from 0 to positive infinity. For g of x, the range is from negative 4 going up to positive infinity. Okay, next what we're going to talk about, we're going to talk about horizontal shift. Next transformation, horizontal shift. Horizontal shift. So for horizontal shift, we're going to have two translations, horizontal shift to the right and horizontal shift to the left. So we're going to start with horizontal shift to the right. Okay, so f of x, it's the parent function, it's original function. And g of x, it's going to be the function f in the parenthesis x minus 3. I'm sorry, not minus 3, x minus c. So what we're going to say that g of x is the horizontal shift by c units to the right of f of x. Okay, so now what's going to happen, you're going to have original function and we're going to push that original function to the right. So y values won't be affected, the height of the graph won't change, however x values will be changed. So let's write note note that horizontal shift affect x values. Affect x values. Y values stay the same. Y values stay the same. So let's do the example. Example, use the graph f of x equal square root of x to obtain g of x, which is equal square root of x minus 2. So how are you going to know that you have a horizontal shift? The change is going to affect the x. So you're going to see the change right next to x. You're going to see x plus 2, x minus 2, or of course different coefficient. So that's how you're going to know that we're dealing here with horizontal shift. And of course, we will find the domain. Find domain of g of x. So find domain and range. We're going to do both, domain and range. Of g of x, which is our horizontal translation. So note, because you're going to notice that in a second, but I want to write it now. Horizontal shift we have horizontal shift because we see changes involving x values. Okay. Now in parentheses for vertical shift, the new function will have equation g of x equals square root of x minus 2. So that 2 will be outside of the square root of x. So in this case, like you see, x is not affected in vertical shift. However, we're going back to our example, which is horizontal shift. So how are we going to do it? We're going to graph it together. Okay, so let's go back to the problem. So graph f of x and g of x together. So let's create the table of value. We have x, f of x is equal square root of x, and the last column will be points x comma y. So let's pick 3 points when x is equal 0. y will be equal square root of 0, which is 0. So we have a point 0, comma 0. Then when x is equal 1, y value will be square root of 1, which is 1. So we have a point 1, comma 1. And when x is equal 4, y will be square root of 4, which is 2. So we having point 4, comma 2. Okay. Now let's talk about g of x. G of x. Let's graph it. Let's find the points, which is square root of x minus 2. Okay, so x, g of x, which is equal square root of x minus 2, and we need points x, comma y. So with horizontal shift, it's going to be opposite of vertical shift. So what happened? We're going to have the same y coordinates as original graph, which means 0, then 1, and 2. So the height of the graph is not going to change, however the x values will be different. So a couple things about horizontal shift. Everything what involves x, it works opposite. So if you see negative, that means we have to push graph 2 units to the right. If you have a plus, that means you need to push graph to the left side. So we're going to take our original x, which was 0, and we're going to subtract 2. I'm sorry, and we're going to add 2 because we have horizontal shift to the right. So our new x, take your original x, which was 0, and add 2 because we're pushing graph to the right. So we have 2. So the first point will be 2, comma 0. Next, take original x coordinate, which was 1. Since we have horizontal shift 2 units to the right, so to that original x coordinate, you're going to add 2, and we're getting 3. So the second point has coordinates 3, comma 1. And next, for the third point, take your original x, which was 4. Since we're pushing graph 2 units to the right, add 2. And we're going to have 6. So the next point will be 6, comma 2. Now we have 3 points for original graph, 3 points for horizontal translation 2 units to the right. Let's graph it together. Let's see how the graphs behave. So we're going to graph it. Y. X. I'm going to plug in the original graph f of x, 0, comma 0. So again, let's just put it here that in black it's the original graph, which is just square root of x. So we have a point 0, comma 0. Next point it's 1, comma 1. And the next point it's 4, comma 2. Okay, and this is how the square root of x function looks like. And next, in purple, I'm going to graph g of x. So again, g of x, it's in purple, which is square root of x minus 2. So we have a point 2, comma 0. Next one, 3, comma 1. And next one we have 6, comma 2. 6, comma 2.
Mama is making an online class.
And this is g of x. Okay.
No, she's doing an online class.
I'm still recording, Lucas. So this is horizontal transformation. This is what happened. We pushed the graph 2 units to the right side. Next, what we need to do, we need to find the domain of g of x, and then just write a note. Domain of g of x is not the same as domain of f of x. Since we're pushing graph 2 units to the right side, domain will be different, and in our case the domain it's from 2 to positive infinity. So domain of g of x domain of g of x are all the x's from 2 to positive infinity. Now range of g of x is the same as range of f of x, which is original function, since, like you see, there was no change regarding y values. So going back to the graph, range of g of x and also range of f of x, range is the height of the graph. Like you see, that's the first point right here on the graph, which will be, if you reflect that to the y-axis, so range will be from 0 to positive infinity. So range will be, that's the y values, of course, from 0 to positive infinity. Domain, of course, we're talking here about x values. Okay, so that was the horizontal shift. Let's talk about horizontal translation to the left next. Horizontal translation to the left. Okay, so now we're going to talk about the example when we're pushing graph to the left. So f of x, it's original graph, original function, and g of x, it's going to be f x plus c. So what's going to happen, you're going to see change involving x value, and we're going to add a coefficient to our x. Okay, so you're going to see plus c. Plus means you're pushing graph to the left. With horizontal transformations, always opposite of what you see. Example, f of x, it's equal x squared, and you will have a function g of x, which is equal x plus 2 to a second power. So like you see, we have change involving x value. You see plus 2, that means push original graph. Which will be y equal x squared. Two units to the left. Okay, so be careful. You see plus, you're pushing graph to the left. Next, I want to talk about example from PowerPoint section 3.5. Example from PowerPoint, slide 17. So hold on, give me a second. Let me log in. Okay. Okay, so I'm going to the PowerPoint section. This is section 3.5, and technically, if you know the material, you can view entire PowerPoint from section 3.5 right here. And I want to talk about the slide 17. Okay, we did this. Okay, right here. Combine vertical and horizontal shift, and this is our function. F of x is equal square absolute value of x plus 3 minus 5. Okay. So graph. Oh, it's more in that slide. Graph g of x equal absolute value of x plus 3 minus 5 using transformations. Using transformation, find domain and range of g of x. Find domain and range of g of x. Okay, so g of x let's first describe the transformation. G of x, which is equal absolute value of x plus 3 minus 5. Okay, that's the graph after transformation. What will be original graph? F of x, original graph, will look as y equal absolute value of x, which we should know how that graph looks like. This is just letter v. So we need to describe the transformation. Let's describe transformations. Translations. So look what happened. You have your x is affected by adding 3. Okay, so absolute value is like parentheses. So we have change involving x, so that plus 3 means that we have to push. We have a horizontal shift three units to the left. Why to the left? We talk about it with horizontal translation. It's opposite of what you see. You see plus, that means we're pushing graph 3 units to the left. Next, what happened? You see that negative 5. That negative 5 which stays alone, it's your vertical shift. So here we have vertical shift. Maybe let's change the color. Let's make more orange. So we have vertical shift And when you have vertical shift, again, what you see, it's true. You have -5, so we have vertical shift 5 units down. Okay, so let's graph it. Okay. So let's create a table of value. Again, I don't want this color. F of x, which is the absolute value of x. Let's review. You have x, y equal absolute value of x. And let's pick 3 points, x comma y. So when x is equal 0, you have absolute value of 0, which is 0. So you have a point 0 comma 0. Have 0 comma 0. When x is equal 1, you have absolute value of 1, which is 1, so you have a point 1 comma 1. And when x is equal -1, you have absolute value of -1, which is 1. So we have a point -1 comma 1. So now your new graph, which is g of x, when we have two translation together, absolute value of x plus 3 minus 5. So I'm going to use the original graph to find the new coordinates. Okay, so since we have vertical shift, so let's talk about those points. So since we have vertical shift, so what happened? We have, we have horizontal shift 3 units to the left. So you take your original x and you subtracting 3 because we're pushing graph to the left. So our original x will be -3. So that will be our new point, -3. Now what's going to happen to the y value? Originally you had 0, but since we have that vertical shift 5 units down, so what's going to happen? Take that original y coordinate, which was 0, and subtract 5. Okay, maybe I'm not going to put it here. So you take that 0, subtract 5, and you end up with -5. Next, the second point, which we have 1 comma 1. So let's talk about the x's. We have horizontal shift 3 units to the left. So when x is equal 1, from 1 subtract 3, we end up with -2. So we have a point -2. And the y value, originally you had 1. We're pushing graph 5 units down. So from 1 subtract 5. You subtract 5. And you will end up with -4. And next one more. Originally, our function has the x coordinate equal -1. So take that -1. We're pushing graph 3 units to the left, which means we're going to subtract 3 from original x coordinate, and you end up with -4. And for the y coordinates, originally you have 1. We're going to subtract 5. So subtract 5, so 1 minus 5, we're going to end up with -4. Okay, so let's graph both of them together. X. So in black, I'm graphing the original absolute value of x, 0, 0, 1, 1, -1, 1. 0, 0, 1, 1, and -1, comma 1. And this is f of x equal absolute value of x. And in blue, this is the g of x when we have horizontal vertical shift, which is absolute value of x plus 3 minus 5. So we have a point -3 comma, like we talk about it. You take your original point, you pushing 3 units to the left, 1, 2, 2, 3, and then we pushing graph 5 units down. 1, 2, 3, 4, 5. Okay, so that's how we end up with that point -3 comma -5. Then the second point, -2, -4, how that point was created. You take the point 1 comma 1, we're pushing 3 units to the left, 1, 2, 3, and then we're pushing 5 units down, 1, 2, 3, 4, 5. Okay. And then the next point, -4 comma -4, we taking the point -1 comma 1, we're pushing 3 units to the left, 1, 2, 3, and 5 units down, and we'll end up right here. So this is g of x, horizontal and vertical shift. Okay, I'm going to stop here, and you're going to see the next video with section 3.5.